Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session, we are going to revise the complete chapter, that is a friction. So far, let me give you a brief description what we have done before. We have done lectures on friction and solved the problems, and around 5 lectures, but here we are going to give in one lecture the total sum and substance of the chapter friction. Let me summarize here. What is the friction? We have covered the friction is nothing but, if a block of one substance is placed over the other, a level of the surface of same or different material, a certain degree of interlocking or of the minutely projecting particles takes place between these projecting particles, takes place this interlocking. So that projection of interlocking, the degree of interlocking of the minutely projecting particles happens. This interlocking makes the body, develops the inertia such a way that it acts against the motion of the body. So this does not involve any force so long as the block does not move or tends to move. But here there is opposing force that takes place when it is in opposite direction of the motion. That the force which opposes the motion of the body, then it is known as a friction force, or simply known as a friction. Now here the friction means frictional force. The frictional force and also friction is measured or quantified in terms of a coefficient that is known as a coefficient of friction. Now the frictional force, the types of friction, there are two types of friction. One is static friction, another one is the dynamic friction. What is the static friction? The static friction experienced by a body when it is at rest. The body is at rest, then that body experiences a static frictional force. What is the dynamic friction? When the body is under a motion or movement, the body experiences this type of friction that is known as a dynamic friction or kinetic friction. This dynamic friction is classified into two types. One is sliding friction, another one is rolling friction. Here, the motion is, there are two types of motions. You may call it as a linear motion and angular motion. But the body experiences this linear motion causes this called a sliding. When body slides, when the body moves, it is a linear motion, but that body experiences the sliding action. That's why this dynamic friction is known as also, sliding friction is also known as a dynamic friction. And angular motion, rolling, the wheels, the automobiles were rolling, the front wheels and rear wheels under motion, then it is known as the rolling friction. This rolling friction takes place experienced by the body when it rolls over another body. And sliding friction experience when it slides, the body slides over another body, then it is known as the sliding friction. Now, there is a frictional force when body tends to move. There is a maximum frictional force that is known as the limiting friction. The maximum value of the frictional force which comes into play when a body just begins to slide over another surface of the other body, then it is known as limiting friction. This limiting friction is nothing but a maximum frictional force. Now this limiting friction or normal reaction or the frictional force, this diagram shows all the terms can be seen here. The weight, the maximum weight acts vertically downwards. The maximum weight of the body vertically downwards takes place. There is a term is known as the normal reaction. This normal reaction is normal to the surface. Normal to the surface. Now here there is a limiting friction or maximum frictional force. When the body thrust is moving in this direction, when you apply this thrust, suppose 1 Newton, the body doesn't move. And if you apply 10 newtons force, there is a limited frictional, where there is a force. At that limit, the body tends to move. At that time, the maximum frictional force takes place. That is known as the limiting friction. The movement of the body in this direction, the direction of the applied thrust. So here the term normal reaction, limiting friction, movement and the thrust and weight of the body, maximum weight. This mc weight acts normal, always passing through the center of gravity of the body. Alright, these are the terms. There are certain laws for limiting friction. Some of the laws are the direction of the frictional force or limiting friction is always in the direction of, in opposite to the direction of the motion of the body. Okay, and the limiting friction always acts tangential to the two surfaces that are in contact. And third one says about the magnitude of the limiting friction. So the magnitude of the limiting friction and the normal force between the two surfaces are directly proportional. And the fourth one is the limiting friction is dependent on the material, on the nature of the surfaces that are in contact, on the smoothness. The limiting friction, last one is called, what is the independent of the limiting friction? The limiting friction is independent of the shape and the area of the surfaces. So limiting friction depends on the type of the material and the surface in contact, that are in contact, and the smoothness. And the limiting friction is independent. One is a dependent, another one is the independent. What type of it is independent? The limiting friction is independent of the shape, geometric property, and the area of the surfaces. Alright. Now, various examples of the limiting friction. When we walk on the road, one of the example, and also when car moves on the road, okay, and also when the person carries carries the weight, that grip takes place because of the friction, okay, and we are able to sit on the chair, okay, not moving, otherwise without sliding because of the frictional force. So these are the various examples which are mentioned here in order to understand the practicality and or applications of the limiting frictional force. Now, the normal reaction which we discussed already, it has been experienced whenever your body lying on a horizontal or inclined surface which is in equilibrium, its weight acts vertically downwards passing through its center of gravity. But whereas the normal reaction which always acts in upward direction on the body, but the reaction is always perpendicular to the plane and not to the surface. Yeah, perpendicular to the plane of the surface, always normal to the plane, is generally denoted by normal reaction, denoted with R. The units for normal reaction is newtons, and whereas for thrust, unit for thrust, unit for limiting friction are also in newtons. And the weight is also in Newton. Weight is always acts downwards and passing through its center of gravity. Now, yes, here it will be interesting to know that one of the terms, this normal reaction, is very important, the field of friction, as the force of friction is directly proportional to it. The force of friction is directly proportional to normal reaction. Now here, the force of friction is directly proportional to normal reaction R. Then F equal to mu times R. There is a mu equal to F by R. This mu is the coefficient of friction. Alright. This F is the force and R is the normal reaction. Frictional force. F is the frictional force and whereas R is the normal reaction. This coefficient of friction develops the relation between normal reaction and the limiting friction. Now here, this diagram shows that relation between the friction and applied force. Now, there are the two types of zones are there. One is static friction zone and another one is dynamic friction zone, that is known as the kinetic friction zone. Here, less than the limiting friction, the junction between these two, the difference between static friction and dynamic friction, geometrically you may call it as the body at rest, or another one, kinetic friction, means in the body is under motion. But if you come to conceptual point of view, the difference, the edge, is the limiting friction force. the maximum limiting tends to move after the limiting friction. When the force, applied force, crosses the limiting friction, then the friction is known as the kinetic friction. If the applied force is within less than the limiting friction value, then that zone is known as the static frictional zone. Otherwise, the maximum is above the limiting friction value is known as the dynamic friction zone. So this limiting friction is the junction between static and dynamic friction. Here from this diagram you can understand. Now here this limiting friction is the maximum value. You can understand the maximum frictional force, where the static friction is less than the limiting friction value and kinetic friction is also less than the limiting friction value. And the maximum frictional force value is known as the limiting frictional value, at which the body tends to move. If the force crosses the limiting friction, the applied force, then the limiting friction value decreases and the body is under motion. Now you can understand it is a decreasing. The maximum, the frictional force, the friction is getting reduced. At the limiting frictional force, the coefficient of friction is high. Understand, the coefficient of friction is maximum. Alright, this is very, very important diagram to understand the relationship between static friction and dynamic friction, and also coefficient of friction and the applied force. Okay, now the next one is angle of the friction. What is the angle of plane and angle of friction? Now here, in this, there is a weight. We consider on inclined plane. On the inclined plane, here the body tends to move downwards, whatever frictional force which acts in opposite direction of the motion of the body. Whereas the normal reaction always acts normal to the plane or normal to the surface of the plane. Whereas the weight of the body which acts downwards, vertically downwards. Alright. Whereas the alpha is the angle of inclined plane. This angle of inclined plane is gradually increased till the body tilts. The body just starts sliding down the plane. This angle of inclined plane at which the body just begins to slide down the plane is known as the angle of friction. Now, understand here, the angle of inclination is alpha as soon as the body doesn't slide down on the plane. At the angle at which the body slides, tends to move down, that angle is known as the angle of friction. That angle of friction is denoted by phi. That is known as angle of friction. That's why here the coefficient of friction mu equal to tan phi. Okay, that is also coefficient of friction. This in terms of tan theta, tangent here, that is called tan phi. Now this is also equal to the angle which is normal, which the normal reaction makes with the vertical. Now coming to the mu equal to tan phi means what? Coefficient of friction. The coefficient of friction is also denoted in terms of derived expression, that is mu equal to F by R, where F is the maximum frictional force or limiting friction. Limiting friction is nothing but a maximum frictional force. Okay, and whereas R is the normal reaction. This normal reaction depends on what? Normal reaction depends on the contact surface and weight of the body. So this normal reaction is the normal reaction between the two bodies. F equal to mu times R, where mu equal to F by R. What is the unit for coefficient of friction? Here mu equal to F by R. Unit for F is newtons, unit for R is newtons. Okay. Whatever the unit for mu, coefficient of friction, is the unit less, is the factor, it denotes. Okay, mu, it doesn't have any units. Okay. Now this is a relation, this is the description about the coefficient of friction. Now different laws we covered here. Now coming to the problem solving, with those concepts, we are going to solve the problems. Now, here the a body of weight is 300 newtons, is lying on a rough horizontal plane, having a coefficient of friction is of 0.3. Find the magnitude of the force which can move the body while acting at an angle of 25 degrees with the horizontal. Okay. Now here, this is the board in this figure. and having 300 newtons weight which acts downwards in the horizontal plane. That's a normal reaction is also passing through the center of gravity of the body, and it is a collinear force. Now here in upward direction and the 25 degrees it is making an angle. Now mu equal to 0.3 and weight is 300 newtons, and let P is the magnitude of the force which can move. This is the P is the force. Now what to be found? Now make it resolve this P, that is a horizontal and vertical components resolution, that is P cos 25 and P sin 25. Make it horizontal, that is horizontal. Here how to solve the problems? What is the prerequisite? Yes, we need the concepts of knowledge of equilibrium conditions. That is horizontal equilibrium and vertical equilibrium. That is sigma fx equal to 0, algebraic sum of all the horizontal forces equal to 0, and sigma fy equal to 0, and algebraic sum of all vertical forces equal to 0. Now we apply these two equilibrium conditions and we get into the unknown parameter going to be calculated. Here resolving the forces horizontally, that is F equal to P cos 25, that is P times cos 25 is 0.9063. And resolve the forces vertically, that is R equal to W minus P sin alpha, that is 300 minus P sin 25. That is R equal to 300 minus P times sin 25, that is 0.4226. We know that the frictional force F equal to mu times R. What is the F equal to? F equal to P times 0.9063. That 0.9063 or P equal to mu times R. What is that R here? 300 times 300 minus P times 0.4226. Substitute over here and calculate the minimum effort required in order to overtake the body slide to move. That is 87.1 newtons. Minimum force is required. The force of the weight of the force, that is 300 newtons. Okay, 300 newtons force. What is the horizontal force is required? You want to pull the horizontal force. That is PH equal to P cos 25. That is 87.1 times cos 25.905 times 87.9063. Then we can know that this value, that P horizontal, and P vertical force, the body can move, that is P sin 25, that is 87.5 times sin 25. That is sin 25 0.4226. Alright. Now here the P value is the value 87.1 newtons with an inclination of what? 25 degrees. When the P is applied, effort applied with the 25 degrees, the P is required is how much? 87.1 newtons force is required with an angle. The angle is here 25 degrees. If it is 30 degree, it will vary. If it is 45, it varies. So the effort also varies in terms of the angle of inclination with which the load applied on the body. Okay. Now the next problem is that a body is resting on a horizontal plane, rough horizontal plane, required a pull of 180 newtons inclined at 30 degrees to the plane just to move it. Okay. It was found that a push of 220 newtons inclined at 30 degrees to the plane just moved the body. Determine the weight of the body and the coefficient of friction. Determine the weight of the body and the coefficient of friction. We want weight of the body and mu. In previous problem, we have to calculate P, effort. Here we have to calculate W and mu. Okay, now, first of all, consider a pull of how many newtons? Here 180 newtons acting on the body. We know that in this case, the force of friction will act towards the left direction, because in this direction now resolve 180 cos 30, 180 sin 30, vertical and horizontal, 180 cos 30 and 180 sin 30. And F1 is acting in opposite to the direction of the motion. That is F1 equal to 180 times cos 30, that is 155.9 newtons. And R1 is the normal reaction, that is vertical equilibrium condition if we apply. That is W minus 180 times sin 30, W minus 180 times sin 30, 1.5, W minus 90. That is 155.9 equal to mu times R1. What is that? R1 equal to W minus 90. That is one of the equation. Now another force, the push of 220 newtons with an angle of 30 degrees. Again resolve horizontal and vertical forces. That is Ft equal to 190.5 and R2 equal to W plus 110 newtons. Now we know that F equal to mu times R2. That is 190.5 equal to mu times R2. That is W plus 110. the equation number 2. From equation 1 and equation 2, what is that? Divided by equation 1 by equation 2, 155.9 by 190.95 equal to mu times W minus 90 by mu times W plus 110. Cancel mu and obtain the value of the W. The W is 991.2 newtons. The next one, we need coefficient of friction. Substitute in one of the equation 1, in one either equation 1 or 2, then we will get the coefficient of friction mu equal to 0.173. The coefficient of friction obtained is 0.173, weight is 991 newtons, provided the push is 220 newtons and the pull is how much? 180 newtons with an inclination of 30 degrees and 30 degrees both push and pull. Okay, when the push or pull, both 220 newtons push 30 degrees and 180 newtons pull 30 degrees, the coefficient of friction and the weight remains the same. The weight is 991.2 newtons and mu equal to 0.173. Alright. So this is the model number 2, and coming to the model number 3. So far we covered the problems of single body problems. Now here it is the two blocks, double body problems, multiple body problem. The two blocks A and B of weights 1 kilonewtons and 2 kilonewtons respectively are in equilibrium position as shown in figure. If the coefficient of friction between the two blocks as well as the block B and the floor is 0.3, find the force P required to move the block B. What is the force required to move the block B? Yes. What is the force P? Effort required P. And mu A between A and B contact surface, mu between A and B and floor is remain same, that is 0.3. Okay, then for the two body problems, what to do? We have to draw free body diagrams. And after drawing the free body diagrams, apply equilibrium conditions. The equilibrium horizontal and vertical equilibrium conditions, then we'll get it. The required objective. Now let us consider the free body diagram of the body A, block A. The free body diagram is here. The frictional force, the tension force is T, and R1 normal reaction R1, W is the weight is acting downwards 1 kilonewton. The frictional force is opposite to the direction of the motion of the body, that is F1. Now R1 resolving the forces vertically. Now R1 plus T sin 30 equal to 1 kilonewton, that is T sin 30 equal to 1 minus R1. I have explained, already the in detail explanation was taken place in previous sessions. Here I am summarizing what we have done. That's why a revision. That's why I am going ahead, because how to make it again? Here you are watching this only this video. Then what to do? Horizontal T cos 30 and T sin 30. Resolve to resolve. What is the vertical equilibrium? T sin 30 plus R1 equal to 1 kilonewton. 1000 newtons. Now T sin 30 equal to 1 minus R1. Now again resolve horizontally. What is the horizontal close? T cos 30 and F1. T cos 30 equal to F1. That F1 equal to mu times R1. That is 0.3 times R1. Now equation 1 by equation 2. What is the equation here? T sin 30 equation 1. This is equation 2. Equation 1 by 2. That is sin 30 by T cos 30 equal to 1 minus R1 by 0.3 times R1. T get cancelled. R1 will be obtained. What is that R1 here? The R1 equal to 0.85 kilonewtons. Substitute this R1 in one of the equation, you will get it. What is that? F equal to mu times R1, unknown, or F equal to mu times R1. F1 equal to, what is the F1 equal to mu times R1? Mu is 0.3 and R1 is 0.85, that's 0.255 kilonewtons. Okay, next, it is not sufficient. We need the frictional force between where? Block B and the floor. Okay. No, the effort P is required. Alright. Now R2, we already know now free body diagram of block B. The tendency when it is the effort P is moving this direction, what about F2 in opposite direction? Now apply what is the horizontal equilibrium, vertical equilibrium conditions. R2 equal to 2 kilonewtons plus R1. What is that? R2 plus R1. R1 is 0.85, 2 plus 0.85, 2.85 kilonewtons. Now apply horizontal forces. P equal to F2. What is F2 equal to? Mu times R2. What is the mu? Mu is 0.3. 0.3 times R2, that is F2. F2 equal to 0.855 kilonewtons. That is P equal to F2. P equal to, what is the total force between this F1 and F2? F1 plus F2. That P equal to F1 plus F2. that is 1.11 kilonewtons. Now here, this F2 is the frictional force between block B and the floor, whereas F1 is the frictional force between block A and block B. But the coefficient of friction between block A, block B, and the block B and the floor, it is 0.3. Okay, P equal to F1 plus F2, that is 1.11 kilonewtons. Now we covered so far in horizontal forces, horizontal equilibrium. Let us go for the inclined plane problems. Now here, equilibrium of your body on your rough inclined plane subject to a force acting along the inclined plane. Now the minimum force P1, which will keep the body in equilibrium when it is at the point of sliding downwards. When it is point of sliding downwards, what about the direction of the friction force? It acts in opposite to the direction. So downwards means opposite direction. This one is the direction opposite. Now the normal reaction, normal to the inclined plane, and weight is acting, passing through the center of gravity of the body and vertically downwards W. Now apply the equilibrium condition, horizontal equilibrium along the plane and normal to the plane. We are going to apply it. Now that P1 equal to W sin alpha minus mu times R1, and perpendicular to the plane R1 equal to W cos alpha. That P1 equal to mu times R1. Now substitute here R1. What is R1 equal to W cos alpha? That is W sin alpha minus W cos alpha. That is W times sin alpha minus mu cos alpha. That is P1. What is the mu equal to? Mu can be substituted as F by R, and also mu equal to tan phi in terms of angle of friction. Now mu1 equal to, substitute here, mu equal to tan phi. That is P1 equal to W times sin alpha minus tan phi times cos alpha. What is the tan phi equal to sin phi by cos phi? And further simplification if you do, that is P1 equal to W times sin alpha minus phi by cos phi. Now that is the minimum frictional force. What about maximum frictional force? The maximum frictional force, that means the body moves upwards. At that time, what will happen? The frictional force, the body moving downwards, whatever direction of the frictional force is downwards. That is Ft equal to mu times R2. Again, the apply equilibrium condition along the plane and normal to the plane. Then P2 you obtain as P2 equal to W times sin alpha plus phi times cos phi. Before, P1 equal to W times sin alpha minus phi by cos phi. Here the W times sin alpha phi plus sin alpha plus phi by cos phi. These are terms. In terms like that, we have to solve. In detail, here it is mentioned step by step. Go through it, you will understand. Yes, Pakka, it is guaranteed to be, you can understand very well. Okay. Now, we explained what is the detailed descriptions of what about, on inclined plane and vertical plane. Now here we are going to solve the problems on inclined plane. Okay. What about friction problems on inclined plane? This is the problem. A body of weight 500 newtons is lying on a horizontal plane, horizontal inclined plane at an angle of 25 degrees with the horizontal. It is supported by an effort P parallel to the plane as shown figure. Determine the minimum and the maximum values of the P for which the equilibrium can exist if the angle of friction is 20 degrees. Here from this data, the obtained figure, it is the P is inclined and F is the direction of frictional force direction downwards, 25 degrees and 500 newtons downwards. Now, the minimum force required, we already derived expression in previous slides. That is P1 equal to, for that case, inclined plane case, that is W times sin alpha minus phi by cos phi. That is W 500 times sin alpha 25 minus 20 by cos 20. That is 46.4 newtons in detail. Yes. That is the minimum force. The maximum value of the force, P2 equal to, what is the derived expression for on inclined plane for maximum force, that is W times sin alpha plus phi by cos phi. That is W is 500 newtons, sin alpha and phi is 25 and 20 degrees. Substitute over here. The obtained answer is 376.2 newtons. Now, next another problem. A body of weight 500 newtons is lying on a horizontal plane, rough inclined plane, an angle of 25 degrees with the horizontal. It is supported by an effort P parallel to the plane is shown figure. Determine the minimum maximum values already derived. Yeah. Now here an inclined plane, another problem. This is inclined plane. They did not mention the angle of inclination. It was given for this problem 2.4 meter horizontal and 1.22 meters. And how to find out the angle of friction? Tan alpha equal to 1.2 by 2.4. We can get the answer. Now here the coefficient of friction mu equal to 0.3. What is the condition here? It is the real field problem. State whether it is necessary to push the body down the plane or hold it back from the sliding down. What the minimum force is required parallel to the plane for this purpose. Now tan alpha equal to 1.2 by 2.4, alpha is obtained as 26.5 degrees. Whereas now horizontal, now here apply the equilibrium condition. Now R equal to W cos alpha, that is 400 times cos 26.5, that R is obtained as 357.9 newtons. The force of friction F equal to mu times R, where is the mu equal to 0.3, what is the R value? 357.9 newtons. So substitute over here, the obtained friction force is 107.3 newtons. Now result the 400 newtons along the plane. The obtained equation is 400 sin alpha. The 400 is sin 26.5 degrees. Now 400 times sin 26.5 is 0.4462. That is 178.5 newtons. Now, as the force of the friction along the plane, which is responsible here for sliding down, it is the sliding as the force along the plane is greater, that is more than the force of friction. Here the obtained, that's therefore the body will slide down. So, or in other words, it's not necessary to apply to push the body down the plane. Alright, because the force along the plane is already larger than the force of the friction. Now, what about the minimum force required parallel to the plane? That is the difference between 178.5 and 107.3, that is 71.2 newtons. Okay, do you understand here? The sliding down the force which is obtained here, the frictional force is 107.3. Along the plane force is 178.5 newtons we obtained here. This 178.5 is greater than the maximum frictional force, the force of friction, that is 107.3. That means no need to apply any force. Automatically the body will be slided down. That is what meaning is. The next problem is already solved in previous sessions, but I am going to revise it. Now an effort of 200 newtons required just to move a certain body up an inclined plane at an angle of 15 degrees. The force acting parallel to the plane. If the angle of inclination of the plane is made 20 degrees, the effort required, again applied parallel to the plane, is found to be 230 newtons. Find the weight of the body and the coefficient of friction. Now here it is, 200 newtons, the 15 degree, here the angle of inclined plane, the tendency of the plane is moving upwards, the force of friction is acting downwards, normal reaction normal to the plane, and weight is acting downwards. Now result the forces along the plane and normal to the plane. Now along the plane, that is 200 equal to F1 plus W times sin 15. F1 equal to mu times R1. Mu R1 equal to W cos 15. Now substitute over here 200 equal to W times mu cos 15 plus sin 15 degrees. Now consider the body lying on a plane, inclined plane. The angle of inclination, before it is 15 degree, now it is 30 degree. Now same thing, methodology, if you apply it, now 230 equal to W times mu cos 20 plus sin 20. Now divide one equation by another equation to obtain the mu and the W values. The coefficient of friction is obtained as 0.259. Whatever the W, substitute in one of the equation this coefficient of friction value in above equation, either equation 1 or equation 2. The W will be obtained. The obtained W value, weight of the body is 392.9 newtons. Alright. Now coming to, so far we covered horizontal and vertical frictional forces. Alright. On horizontal plane, double body problems. On inclined plane, single body problems. Now we are going to consider the ladder friction. This ladder friction comes under the application of the frictions. The application of the friction, there are two types of applications we are going to solve here. One is the ladder, another one is the wedge friction. What is the ladder here? The ladder friction, ladder is nothing but a device which is used for climbing or scaling up on the roofs or walls to fit the electrical fixtures. Now here, when the ladder, one edge is here, another edge is here, there is a contact. The top edge at point B is the contact between the ladder and the wall, and at point A, the ladder and the floor. When there is a contact, there are the two things, frictional force. Now normal reaction and coefficient of friction of the wall, coefficient of frictional force. This alpha is the angle of inclination. Now how to solve the problems? Now here apply equilibrium condition, horizontal and vertical also. Now a uniform ladder of length 3.25 meters and weight is 250 newtons is placed against a smooth vertical wall with its lower end 1.25 meters from the wall. Okay, the coefficient of friction between the ladder and the floor is 0.3. What is the frictional force acting between the wall and the ladder? That's what we are going to find out. Well, let us see. The length of the ladder is 3.25 meters and the weight is here 250 newtons acting downwards. The bottom edge is 1.24 meters away from the wall at point A and point B. Here point B, what we want to find out at point coefficient of friction force. Yes, between wall and the ladder. Am I right? What is the frictional force acting ladder and the point of contact between the ladder and the floor? We want coefficient of friction at the floor. Mu F is required. Now RF equal, what about RF equal to 215 newtons? And what about BC here? The length BC equal to, according to Pythagoras theorem, hypotenuse square, diagonal side square equal to opposite side square plus adjacent side square. From that we are going to find out the opposite side here, that BC equal to 3 meters. Now apply the moment equilibrium. Now FF into 3 equal to RF. FF into 3 about which point? Okay, this FF into 3, this distance point B, that equal to RF times 1.25 minus 250 times 0.625, that FF equal to 52.1 newtons. Okay, what is the equilibrium of the ladder? The maximum force of friction available at the point of contact between the ladder and the floor, that is mu RF, that is 0.3 times 250, that is 75 newtons. Okay, these are the problems we solved. Go through it more thoroughly. This is the problem model number 2 of in the case of ladder friction. Now coming to the wedge friction. A wedge is nothing but a triangular or trapezoidal in cross section. Okay, it is generally used for what purpose? Slight adjustments or slight adjustment in the position of the body, or for tightening the feet, or keys for shocks. This is the wedge. This portion is the wedge. This is the body. When wedge is moving in this direction, the body will be more lifted upwards or adjusted. Okay, if we apply the equilibrium conditions here, we have to draw the free body diagrams. This is the wedge or the weight of the body. R2 is the reaction force. R1 is the reaction, and making an angle of friction, that is the phi and phi. Make it R1 cos phi, R1 sin phi, similar R2 cos phi and R2 sin phi. And apply the equilibrium conditions, horizontal or along the plane. There are two things. One is horizontal plane and vertical plane, and also along the plane and normal to the plane you have to apply. Now a block of weight is 1500 newtons overlying a 10-degree wedge on a horizontal floor and leaning against the vertical wall is to be raised by applying a horizontal force to the wedge, assuming the coefficient of friction between all the surface, all the in contact is 0.3. Now go through it in detail. Okay, we already solved. Just revision I am doing here. Okay, you will get it. That R2 equal to, apply the resulting forces on the body, that is R1 cos 16.7 equal to R2 sin R2 sin times sin of 10 plus 16.7. This is R2 and R1 equation relation between. Another one, resolving the forces vertically, then you can find out R1, substitute this R1 in R2 equation, then R2 can be obtained. Okay, thus we can solve. These are the forces. So these are the various definitions which already covered. What is the fluid friction? What is the non-viscous friction? Okay. These are in details. What is the limiting friction? What is the defining angle of friction? What is the kinetic? These are the things. Now examples of the friction at our homes. This is the matchstick which match when it rubs due to frictional force. The fire comes into the picture. Brushing your teeth at home and walking on the floor on rough inclined surfaces and hammering the nail on the wall. The grip between the nail and the wall is the friction grip. Okay, and here you can see the need for mopping. Yes, the mopping also due to frictional forces. These are the various types of frictional forces. Okay, and outdoor settings, you can see sandpaper grinding, kids are sliding on a slider. These are the outdoor settings. In nature, okay, very important here. Due to friction, there is rubbing between two bamboo sticks. The fire comes due to friction. It catches the whole forest to get into the fire. And this friction can't be, the fire can't be extinguished by or switched off by whatever fire extinguishers. It can be only by rain. Can be. There are 10 examples. These are the friction fluids. Due to fluid friction, swimming in water, water flow in the river, water flow through pipe systems, the flow in ink pens. The water flow through pipes, again the coefficient of friction, that is head loss due to frictional force. There we'll use Heisenberg-Poiseuille's equations. Yes, these are all the various frictional forces. And one more aerodynamic, 10 examples of air friction. So movement of aircraft, air resistance on your hand, skydiver, flying of the boats or bats, press during a cyclone, flying of a flag, swaying of a balloon, windcock, all these are examples of air friction. Yes, these are the references were followed in the session, complete session. Okay, this is the complete sum and substance of the module, that is the frictional, about the friction. With this, we can wind up. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.